for Gemma. Okay, so we've got the area. We need to have the sum of the 5 sides. We've got the base lengths, but we don't have a height. So let's use this variable h, because that's ultimately what we're going to solve for here. We're asked to show that h is 8 minus x centimeters. So what are the areas? Well, I've got a base area that's going to be x times 2x. That's my base area. Plus, I've got 2 of the front and the back. Those are going to be the same. Those red sides there are all going to be x times h, and I've got 2 of them. And I'll have 2 of the blue sides, which are going to be 2x plus h. So 2 of 2x times h. Alright, so this is going to be 48x minus 4x squared is equal to 2x squared plus 2hx, and that's going to be plus 4hx. So we can do some grouping and factorizing and things on the right hand side there. That'll give me 2x squared. If I take out a common factor of 2h between those terms, and the reason I'm taking out, in fact, let me just take out h, is simply because I want to solve for h. So I'll leave that as 2x plus 4x. That's going to give me 6x in the middle there. I could have added those like terms. And then we sort this out. So let's take the 2x across. So that's going to be 48x minus 6x squared is equal to 6xh. Divide this all by 6x. That's going to give me 48x over 6x minus 6x squared over 6x. And that leaves me with h. And simplifying this, x's are going to cancel. That x cancels with the squared. The 6 cancels there. 6 cancels with 48 to leave me with 8. And so, hey presto, h is equal to 8 minus x centimeters.
Thank you. I got to the third step, but then I wasn't sure where to go from there. So
to this line here.
Yeah. So that's just the dividing part I didn't get.
Yeah, it's just solving for h. Literal equations. In theory, that's grade 8 work.
Yeah, I just didn't take the h out. I took the x out. So
Okay. All right. No, fair enough. Tyler?
Mr. Norton, what is the answer for B?
Determine the largest area of the box. So we know that the area is equal to 48x minus 4x squared. So in order to find the largest area, I'm going to have to optimize this and find dA by dx, which is going to equal 48 minus 8x. Yes, I think that's right. Solve that
Mr.
for...
Norton,
Yeah?
why did you not say x times 2x times 8 minus x?
X times
get the volume.
2x times
8 minus x.
Because they're asking for the volume.
Yes, and x
Yeah, so it's in
times
volume.
2x times 8 minus
Times
x is volume. Yes, we should be doing that because I'm solving for the largest area, which isn't particularly intelligent of me. So yeah, Tyler, I think you're right. We'd have to work out volume. So our volume is going to be 2x squared times 8 minus x.
8.
Multiply that out. That's going to be 16x squared minus 2x cubed. So now I can solve the derivative of volume. dv by dx is equal to 32x minus 6x squared. Solve that for 0.
We get 5.3 recurring or 0, I think.
So we get either x is 0 or we get, yeah, 6x is equal to 32, which is, what did you say, 5 1/3?
16
Yeah.
over 3. Yeah.
5.3 recurring. So,
Well, they
yeah,
normally
then,
give us nice numbers.
I beg
Or
your
like,
pardon?
is it common for them? Will they normally give us nice numbers, or like, is it quite probable that they'll give us recurring in decimals and stuff like
Well,
that?
this is a fraction. This is 32
True.
over 6. What's that? 16 over 3. That's a nice fraction. It's not surds.
Okay.
So look, at that point, you've now got to take this and work out what your volume is. So that's going to get a little bit nastier, I suppose. Your volume is equal to 16 times 16 over 3 squared minus 2 times 16 over 3 cubed. And that I'm going to go to a calculator for. This is a bit bright over here. 16 times 16 over 3 squared minus 2 times 16 over 3 cubed. And I get an answer there of 151,70 centimeters cubed.
Thank you.
All right. Okay, yeah, I suppose it helps if you read the question. It was asking about volume there rather than area. Good.
Mr. Norton,
Yes, Tanya.
I've got an unrelated but related question. So you know how you were talking about like we need to scan our work so we can get it to you in one document?
Yes.
So let's say one doesn't have enough space to download a new app. Is it okay if they just put it on Pages and then send it to you through that thing?
Yeah,
I'm
if you can
asking
use
for a friend.
pages to save as a PDF, I'm happy with that. You're still getting your PDF document saved.
Okay, I'll
But
let
please,
my friend know.
I don't have a Mac, so I can't open any Pages documents. So if you put it in Pages, just save it as a PDF, and I know Pages can do that.
Okay, thank you, I'll tell her.
Sure. Tell your friend. Any other questions? Anything else about?
Mr. Norton?
Yes, Savannah.
Sorry, I just want to clarify something you just said. When you go the dv over dx,
Yes.
is that like called optimizing? Like, is that the whole
So this
thing?
is the derivative. Where are we?
Yeah. This
is the derivative, and the reason that we find the derivative is in order to optimize. So optimization uses the derivative. It's one of the reasons we use calculus is for optimization. Yeah, so
Cool,
so
thank
probably
you.
I was using incorrect terminology to call this an optimizing. Yeah, it's not. It's the derivative, and we use the derivative in order to optimize, in order to find a maximum or a minimum. One of
thank
the
you.
questions that does get asked is how do we know that this is a maximum or a minimum? We've got two values that come out of this effectively. And what we know about cubics, again, we know this is a cubic because of that power of 3, is there's typically going to be a minimum or a maximum. It's a negative cubic, so I know it's going in that general downwards direction. So yeah, you could use the coefficient to say, well, the one on the left is going to be, in this case, the minimum, the one on the right is going to be the maximum. In this case, it works out quite nicely that your 0 point will give you a volume of 0, and that, of course, happens to be your minimum volume. A volume of 0 is fairly small, as you might guess. But there might be a scenario where that's not a 0 point, where you get something else like 2 out there, and you've got 2 viable answers, and you've then got to decide which is your maximum and which is your minimum. And again, in this particular example, if we look at the coefficient of x cubed, we can get a general idea of the shape of that cubic graph. and realize that in this case, because we have a negative, the one on the left, whatever it is going to be a minimum. The one on the right is going to be a maximum. If you were in any doubt about that, you could work out the gradient between the two, and that would tell you if it's positive or negative, and that would tell you whether you're going from a minimum to a maximum or from a maximum to a minimum. There are a number of different techniques. Of course, there is always the second derivative that you could work out if you felt so inclined, and if your second derivative was positive, you would end up with a minimum, and if your second derivative was negative, you'd end up with a maximum. That's the kind of mathematically correct technique to use, if you like, but generally we're not fussy about about how you go about deciding whether it's a minimum or a maximum. That's really up to you. Any thoughts, anything else? Any other questions in exercise U?
Mr. Notson, I did the 2011 paper.
Yes.
And it's like a little notational thing that I just wasn't too sure about. But for 4B, they were talking about dx, like capital D, small x. Is that the equivalent of the f of x or the f dash x?
The inside of that, the inside of the bracket is your f of x. The whole thing represents a derivative.
Okay, so you solve inside and then you do the derivative of that. Okay.
So, for example, if we had, and this just to put it in different words, if we had f of x is equal to 4x squared plus 3x plus 2, whatever, f dashed of x is equal to the derivative of 4x squared plus 3x plus 2. So this is a notation to say what we want to do. It's a functional notation, if you like to say we're finding the derivative of whatever's inside the brackets here. You would drop that d notation as soon as you found the derivative. So that, of course, would be 8x plus 3, and you would write that out. So for that question where you have dx of something, if you can take the derivative straight away, you do it. If you have to simplify it, and I think you do have to because there's a fraction, and you write dx for one more step, and then you'd simply write the derivative at the end of that. That was a bit of a nasty fraction. So yeah, this is going to factorize. I'm guessing there's going to be an x minus 3 at the top of that fraction. In fact, there is x plus 3. Yeah, it's a perfect square. So the derivative of x squared minus 6x plus 9 over x minus 3 is the same as the derivative of x minus 3, which is 1. And that's effectively how I would write that. I've skipped out all the factorizing steps there, so take my word for it or prove me wrong if I have it wrong. I might have it wrong, I don't think so. But yeah. Anything else? Any other questions about the test for those of you who've gone through it? Any issues there? It looked fairly straightforward when I had a glance at it. There's some first principle stuff. There's just a plain old substitution question. Determining a limit, I think, is fairly straightforward. What you do need to do, of course, is get rid of that denominator when you find your limit. Otherwise, you end up dividing by 0. Average gradient, do we remember what that is? Basically,
is that the change in y over change in x?
Change in y over change in x. The change in x here is 3 because we're going from 5 to 8. And so it's just working out what the y values are. And yeah, substituting that into the gradient formula. The derivatives, I think, are all fairly straightforward. Of course, the only thing to remember here is you want to write those in exponential notation so that you can do them. The graph of g of x, that's all fine. They've given it to you in factorized form here for a reason, and I'll let you work out what that reason is. But yeah, those are all fairly straightforward questions. Gradients, points of contact of the tangent, equation of tangent. Yeah, you did that stuff right at the beginning. Parabola, not a very well drawn parabola, but there it is. This is the derivative function. Just be aware of that. Go away. I don't know how to make it not blue anymore. Gosh, sorry. There. So that's a derivative function. So we're using this to tell us something about a cubic. So that's interpretation. And then the last one is a bit of a problem solver for you. And this one is, yeah, just formulae, I think. It won't be too difficult. I imagine that your test will be at the same standard as this. I think the purpose of it is more along the lines of what do you know rather than how well can you problem solve after having not been taught a section through traditional teaching means. So yeah, I wouldn't expect anything too horrifically difficult. But if you can answer questions 8 and 9 happily, I think you will be well suited for the test. I've said it's a test. Other classes are being told it's a tutorial or an assignment or whatever it is. Please don't read too much into the words that are being used to describe it. It's going to be an activity that you complete by yourself in a fixed time limit. However you choose to phrase that is up to you. Don't let words get in the way of it. If you want to say it's just an exercise, that's fine. It's going to be questions that have to be done in a set time limit. That's basically it. By yourself. No collaborative working. Could mention names, but I know you know who you are.
Mr. Norton, I feel like you want to say something and that you just want to get something off your chest.
I think we all just need to put the past in the past.
I'm quite happy to, but I didn't ask you to speak. I didn't ask you to defend yourselves. So, the fact that
this is not defending. Just.
Oh, okay. Good,
I feel like you just wanna.
I just noticed that I was substituted, so I just wanted to ask myself.
I mentioned no names. I'm harboring no grudges. But I may just choose to check to see if your answers match or not.
Well,
they will match because we'll get a really good mark.
Exactly.
Yeah, no, brilliant. If you all get 100%, I'll be suspicious and we will start again. That's fine. Clarice asks, how are we going to write the test? Clarice, the answer is with a pen and a piece of paper. And so you'll do it as if it's an exercise in front of you. You'll write it down and then you'll scan your answers and upload them as you've done with your work monitoring stuff throughout. So no new processes, nothing exciting, nothing new. It's just going to be writing it out, scanning it, uploading it, and that's it. So there shouldn't be any particular difficulties there. Because we have to mark this, and that's one of the reasons why I asked you to please upload your stuff as PDFs to at least practice doing that this week, is because it is significantly easier for me to mark a PDF than it is to mark individual images. The tools that Google Classroom puts at our disposal are much more suitable much more suited to marking PDF files than they are for marking images. So it would help me a lot if you can do that. But yeah, if you're struggling to upload it, I'll accept photographs, and if you can then convert to PDF in your leisure, at least I've got evidence that you finished on time, kind of thing. So, yeah, don't stress too much about that, but it would be nice and helpful for me if you could. Any other questions? Anything else? How are you finding this section of work? Optimization is often a, I suppose this, along with the derivative functions, is often seen as quite a confusing section of work. So if you are feeling at all thrown by it, please don't. You're feeling the normal emotions that should be felt with this particular section of work. The fact that none of you have said anything is almost more worrying to me than the idea that you understand it all perfectly. Mainly because if you understand it all perfectly, then my job here is superfluous. And next year I'll just put up some videos and see them before their final exam. Kenya,
Can
yes,
we
ask
use
a
the
question.
This is like, again, unrelated but related. So for exercise U, 1A,
Yes.
when they said determine the areas, this is a question for the class. I just have to know in my soul, was I the only one who first went 10 brackets 60 minus 10 and then got that area and then realized I had to change it to 20?
I did that too. I did that.
Like, yeah, I also did that. I had to do it 3 times before I got the
Same.
right method.
I was like, this is not adding up. This is not adding up. So then I had to go back and to fix all my answers. Okay, I'm just glad that my
Is
brain
that
thinks
just
like other
the
people.
perimeter that you made the error on there?
No, I was just like, oh, you want me to go like 10 times, but I know because of what we've been doing before, I have to go 60 minus 10 to get the length. And then I just realized
Yes.
that was stupid. Then I had to change.
So if you've got two sides of 10, you've got 40 meters left of the rope, so your other two sides have to be 20. Yeah.
Yeah.
Just double checking, is dx the same as f dashed of x? Basically, it is just a notation that lets us represent the derivative of the internal function. So if my f dashed of x is 4x squared, then if my f of x is this 4x squared plus 3x, and f dashed of x could be written as the derivative of that middle term there. Optimization is a bit scary. Yes, it is, because it's putting your faith in a technique that doesn't necessarily have a whole lot of algebraic reasoning and backing. You're doing some magic with some numbers, with exponents and coefficients, and all of a sudden you're making it equal to 0, and there's not a whole lot of intuitive understanding as to perhaps why you're doing that. So yeah, I get it. Taylor, the only thing that I can say in defense of that is the more you practice this stuff, the easier it gets, and I know I say that all the time. But yeah, optimizing is effectively finding roots of derivatives. That's all it is. And if you can get past the magic behind it, then that's easy. The other difficulty, I suppose, and I made the mistake earlier too, is just making sure you're working with the right formulae. But yeah, practice will kind of get you more confident with that, definitely. How many of you, can I ask, have got your either your textbooks with you or have downloaded the electronic versions of the textbook on whatever it's called, Snaplify? Or how many of you do not have textbooks? Okay, if you don't have textbooks, is it I forget what the stupid thing is called. looking it up now. Snaplify. Snaplify is an app that you can get on your phones or your tablets, and you can download the Mind Action Series textbooks and a number of other textbooks for almost all of your subjects for free. They've made it free for the rest of the year because of what we're dealing with. So if you are missing any of your textbooks, have a look at Snaplify, and you can download the textbooks there. There are exercises, of course. We've been working out of the notes entirely. There is an entire textbook full of exercises on calculus that you can go and do, including exercises on optimization and so on. So there, if you want practice, please have a look at your textbook. If you want, in fact, I'm happy to go through it and take screenshots of pages if you want, and I'll post a couple of exercises on Google Classroom if you would like, although that's illegal, and sending photographs of textbooks is technically illegal. So anyway, no one will mind because they've made it available for free, I hope. And none of you will report me, I hope. So I'll do that, and then at least you can get some additional practice from your textbook on the calculus exercises. And also remember the solutions there. Anything else? Any other issues that you want to raise with me? Any other thoughts? I was hoping to go through more of that test today, but I appreciate you saving it until the end of the week. I am then just conscious that we might not have time between now and Monday when you write your test to ask questions. I am prepared to make myself available for an hour or so tomorrow, and we can do it during our lesson time if you want. I won't make it a requirement, but I'll sit online during your lesson time tomorrow. If any of you have questions, I'm quite happy to answer you as you come. If I sit here by myself for 45 minutes, that's also fine. I'm sure I can find something to do on my computer screen to keep me occupied while you ignore me. But if you do want help, I'll be online tomorrow during lesson time, so you can ask questions. The memos, of course, are posted there, so you should be able to check your answers at least. But there might be one or two things that you just have no idea how they got from A to B. So yeah, I'm happy to help with that if you want. Any other questions? Any worries about the test? Anything else? Are you all keeping up with your work? Are you happy that you're keeping up? Are you worried that there is something significant that you are missing? I don't know, anything, just let me know if there are any problems, please. Normally in a classroom, I can see your blank expressions and your disinterested faces from the front, and it's just that much harder to do when your microphones are muted and you are far away. So if there are any issues, just please let me know so I can help. If you
Norton?
don't let me know, it's difficult. Yes, Holly.
It's Holly. Are you gonna post the memo for UNT, exercise UNT?
Exercise T I'll post. Exercise U, I don't have it separated out into 1 and 3, so I was hoping to post that next week. If you want, I'm sure I can just split the pages apart. That shouldn't be too difficult. But T will definitely be posted tomorrow.
Okay, thank you.
Mr. Norton, when
Yeah.
it comes to us submitting our stuff, would you prefer it for us to mark then submit, or submit as soon as we're done?
I don't mind. I honestly don't mind. All
Okay,
I want
cool.
to do is see that you're doing the work. I kind of trust that most of you will be checking your work. Just
Yeah.
because I'm pretty sure that most of you will want to know if you're on the right track or not. So yes, I suppose I'm a lot more lenient than maybe other classes and other teachers might be being at this particular point, but I have a fair amount of confidence that as the first team, you will be wanting to keep on top of what you're doing. So I'm leaving that in your hands. If you're not doing it, if you do have questions, then again, I'm also leaving it up to you to ask.
Okay. Thank you, Mr. Norton.
In as much as, yeah, I can help if you have problems, but if I don't know you have problems, I can't help. And unfortunately, that's the reality of the situation that we're in. So it does require you asking. If you don't want to do it via Google Meets or chat or whatever, then email or send me a private message in Google Classroom or whatever it is. Let's see if I can help however I can. All right. 10 minutes left. If there's nothing else, let me not keep you. I will upload this video for those that appeared and those that didn't. Was it just Gemma that we're missing? I think so. Okay. Good. All right, ladies, thank you very much. Enjoy the rest of your Thursday, and I will, as I say, I'll be online tomorrow. You don't have to join me if you don't want to. If you are feeling confident and on top of everything, by all means, take some time. Hopefully it's a sunny day. Go outside and enjoy some time off if you're up to date.
Thank you, Mr. Norton.
Right.
Thank
Bye-bye,
you.
everyone.
Thank you,
Bye, guys.
Thank you, Mr. Norton.
Bye-bye.
Bye.